Welcome to daily practice. My name is Chetan and I'm going to explain you solution of this question in this entire video. So I urge you to watch this video till end to get a complete understanding about the solution of this question. So let's begin. Solution. Using derivative, prove that sine inverse of x plus cos inverse of x is equal to pi by 2. So using derivatives, we have to prove that sine inverse of x and cos inverse of x is equal to pi by 2. So how to approach such questions? Let's see. First, I will assume sine inverse of x plus cos inverse of x is a function of x. So let f of x be equal to sine inverse of x and cos inverse of x. Now we have to use derivatives concept to prove this relation. So what we will do? We will differentiate this. So differentiate above function with respect to x. So what we will get after differentiation? This f of x will become f dash of x. Derivative of sine inverse is 1 upon under root of 1 minus x square. Derivative of cos inverse of x is minus 1 upon under root of 1 minus x square. Here you can see that 1 upon under root of 1 minus x square and this minus 1 upon under root of 1 minus x square, they both will get cancelled and our value of f dash of x will become 0. Now we know that the value of f dash of x is equal to 0. What does it mean? Which means that f of x is a constant function. So a derivative of constant is always equal to 0. So therefore, as f dash of x is 0, it means that f of x is a constant function. F of x is equal to c, where c is a constant function. Therefore, for any values of x, the value of the function is going to remain constant. Therefore, the derivative of the constant function will be f dash of x, which is equal to 0. Now, f of x is a constant function. Therefore, for any values of x, for any value of x, the value of f of x will remain constant, as c f of x is a constant function. Therefore, for any value of x, the value of function fx will remain constant. So for our simplicity, we will consider value of x is equal to 0. Therefore, consider value of x is equal to 0. Mark this as equation 1, then this as equation 2. Then f of 0 will also be equal to c, which is constant. So mark this as equation number 3. So for any value of x, the value of function fx is going to remain constant. So what we have considered? We have considered the value of x as 0. Therefore, the value of function after substituting x is equal to 0 will remain constant, that is equal to c. Now what we will do? Put x equal to 0 in equation 1. What we will get? f of 0. Now this is equation 1. We are going to replace x with 0. So what we will get? F of 0 equal to sine inverse of 0 plus cos inverse of 0. So sine inverse of 0 plus cos inverse of 0. Now we know the value of sine inverse of 0. Sine inverse of 0 is 0 plus cos inverse of 0 is pi by 2. Therefore, f of 0 will be pi by 2. This is equation number 4. From 2, equation number 2, 3 and 4, we can conclude that sine inverse of x plus cos inverse of x is equal to pi by 2. Hence, it is proved. How? See, from equation 3 and 4, what we have got? F of 0 is pi by 2 and f of 0 is c. So value of constant function is pi by 2. But this c, but this c is equal to f of x, and the value of f of x is sine inverse of x plus cos inverse of x. Therefore, sine inverse of x plus cos inverse of x is equal to pi by 2, as this c was equal to f of x was equal to c. Therefore, f of x will also be equal to pi by 2. But the value of f of x is equal to sine inverse of x plus cos inverse of x. Therefore, sine inverse of x and cos inverse of x will be equal to pi by 2. So in this way, we have proved the given relation using derivatives. So I hope you have understood the explanation and the way how we approach such problems. Then give this video a thumbs up and share it with your friends. If you have doubt, then share it on our Facebook and Instagram handles. See you in the next video. Till then, keep practicing.